So we are in lecture 13, and we're going to finish off the economics of HIV/AIDS in the first half of the lecture, and then we're going to get into human capital education, which will be the next topic, and that'll be the topic we carry forward for the next couple weeks before the midterm. So problem set 2, I'm working on it today, and I will post it tonight, and it'll be due in a week. So that's slightly different than the timing on the syllabus. And again, there'll be different versions for 174 and 274. Any questions before I get started? All right, so let's get going. We've been discussing these key questions in the study of HIV/AIDS and the economics of HIV/AIDS in sub-Saharan Africa. We got through parts of questions 0, 1, and 2, and now we're going to home in on question 3, what can or should public policy do about HIV/AIDS? And what's nice about this question is it's going to build on the model we talked about in point 2 and build on some of the empirical work we talked about. So we're going to have a good foundation upon which hopefully to think through what sorts of policies might be effective. So one policy that I'm going to just briefly mention, and I'm going to relate to the model from last time, is the policy laid out in the DeValk et al. 2012 paper, which we're not going to talk about in detail, but is on the syllabus, and I think will feature in this upcoming problem set. And the idea behind that paper was, is it possible to incentivize people to engage in safe sex? And in particular, is it possible to incentivize them by providing cash transfers to people who remain STI negative? Now, this is a voluntary program. People can choose whether or not to participate in it. If they choose to participate in it and agree to get tested for STIs, say once every 3 months or once every 6 months, and they are STI negative, sexually transmitted infection negative, then they could get a cash transfer. That's the idea. There's actually been a number of projects similar to this over the last few years. And the question is, does this sort of policy have an impact on the rate to which people become infected with sexually transmitted infection? So what I want to do is relate this incentive to the model we laid out last time. There's equations up there, the expected utility equations for both safe sex and unsafe sex that we laid out last time. In the red box, you see an additional term, which is this term I, which is the income or the cash transfer you gain if you remain STI negative. So just for simplicity, imagine you can engage in safe sex and stay STI negative. If you do that, you get this extra cash transfer I. And then the rest of the terms are the same, but if you have unsafe sex, you don't get the cash transfer I. So it's very simple, just adding one term to this model, but it allows us to think through the solution as you expect. This income term I in the red box actually makes unsafe sex look less attractive. Now the left-hand side is going to be smaller. I is greater than 0. So this condition is going to be less likely to hold. Right? So very simple algebra, but you can see how introducing this incentive, conditional on behavior, could be included in a model of this kind with that extra term. Now, in this model here, if you go back to that equation, the model suggests that for an incentive sufficiently large, all individuals will choose to engage in safe sex. And for an incentive that's too small, everybody will have unsafe sex. Like in the model, the way we've been talking about it so far, there's no variation across individuals. They're all the same. They have the same S, they have the same I. There's no heterogeneity across individuals. And that's obviously a limitation of the model we've been talking about so far, because we know different people facing similar situations or the same situation make very different choices. So what I want to do next is I'm actually to show you how we could incorporate heterogeneity into this model. And this is very typical in economic models of decision making. We accommodate some basically distribution of types, some distribution of preferences, some distribution of costs across individuals in order to account for the fact that different people end up making different choices. So this is also important because understanding how different types of individuals react to a particular incentive will feed into the public policy debate. For instance, we want to know at a certain incentive level what fraction of people will change their behavior and choose to have safe sex rather than unsafe sex. If we make that incentive way too large as a public policy maker, we may be successful at getting everybody to engage in safe sex, but it can be really expensive. We may not have the resources to do that. If we make the incentive too small, maybe nobody will change their behavior. So actually understanding who reacts and why becomes important. So if we're going to think through an extension to allow for heterogeneity, which I'll write on the board, imagine the following simple way to understand heterogeneity. Imagine that everybody faces the same incentive I, and everybody values life the same, and everybody has the same biology in terms of life expectancy. Now those are other dimensions where we could have heterogeneity. But let's just assume those away and say the key source of heterogeneity is going to have to do with this S term, which captures the costs and benefits of unsafe sex. And let's allow that term S to be individual specific. So it's denoted now S subscript I. Every individual I can have a different value of that S. And in particular, we can imagine that it's distributed according to some distribution F or whatever we want to call it. But basically there's some spread, some distribution of SIs in the population. So now, allowing for heterogeneity in this dimension means that different people can make different choices. And in particular, individuals with a small enough benefit of unsafe sex, so S sub I less than I minus V times this quantity here, will engage in safe sex, because they don't value unsafe sex much. And people with a very high SI will choose to have safe sex. Will choose to have unsafe sex. Sorry. Low SI means low benefits to unsafe sex, therefore the incentive moves you towards safe sex, and then the opposite for people with high SI. Does that make sense? Let me pause for a second, see if people are getting this. Yeah? That is an incredibly difficult question, and in the DeValk et al. Study, if you guys remember from reading that study, they actually offered multiple incentive levels. And there was some response. I don't want to get into all the empirical details, but they did find that people responded to the incentive they offered. But in the planning for that project, I was involved in some of the early stages of discussions on the planning of that project. Your question, we were asking ourselves that question without really having any grounds for making a decision. What is going to be enough money to change behavior? If you think of people's sexual behavior, the relationships they're in, those are very important things to them, and maybe it would take a lot of money to change people's life choices in that way. At the same time, there's some other evidence, and the Thornton study we'll talk about next, suggests that making, say, a cash incentive very salient to people and very immediate for people sometimes can change behavior with relatively little money. So we were kind of torn and didn't understand what to do. And that was part of the reason why 2 different incentives were offered, to try to get a sense for what kind of incentive you would need to move behavior. But there was no real strong theoretical reason for thinking I should be one level or another. this model could apply to anybody, but S sub I, the values of the S sub I could be very different for people who are 19 versus 50, right? It could be very different depending on whether you're single or you're married, etc. And that's why it becomes very important to think about heterogeneity, because this is an incentive that might move behavior. Let's just imagine that S sub I could actually be negative. Let's bound it at 0 and say the max amount is up here. If most of the distribution is in this higher end, then we would need I to be quite large to change behavior. If most of the distribution is down in this lower end, then maybe a small I would change behavior. And that just becomes a question we have to answer with data or whatnot. So here the thought exercise here is what happens if we increase from I to a higher level I prime? Now all of a sudden different people's behavior gets affected. So in this plot here, look at this here. Let me get rid of these little blocks here. The algebra shows that for people with an SI level less than I minus V times P HIV minus P, they'll choose safe sex. Okay, so let's call that S star. Okay? S star is defined as I minus V P HIV minus P. What that means is everybody with low SIs chooses safe sex, and everybody with high SIs chooses unsafe sex. But there's going to be heterogeneity in the population. Different people make different choices. So what happens when I increases to I prime? Where does S star move? Does S star move left or right? How many people vote right? Raise your right hand. How many people vote left? What's the right answer? A higher incentive means it moves to the right, and now more people engage in safe sex, right? Because as I prime is larger than I, then this quantity moves this way. So now a greater share of the distribution is going to engage in safe sex. This is really what a lot of underlying economic discrete choice models look like. They bring heterogeneity in. And the reason I'm introducing it to you guys, even though the basic model didn't have, you can get the intuition off the basic model, but when you're looking at a paper like Duvall et al., it isn't like everybody chooses one behavior or the other. There's a certain fraction of people who are movable, who are sort of in the middle. It's these people who are kind of in the middle of the distribution that are going to be moved by higher incentives. The people with very, very high SIs or very low SIs are going to kind of stick with their behaviors. Okay, let me pause for a second, see this question. Yeah. Can you speak up a little bit? Mm-hmm. Yeah, so the question was asked about where income of the household comes in here, and we haven't even modeled that here. There is a way to bring it in. Can anybody think of a natural way to bring in household income into this model? What would the extension have to be to this framework? There's a kind of natural way to do that in this kind of framework. Maybe there's more than one. There's one that comes to mind right away. Yeah. So that, as a rule of thumb, that could work. That isn't the way we would typically model it, but that's sort of thinking along the right lines. But we can go a little even more formal than that. Yeah. Okay, so that's similar to this point. I'm thinking along a little bit of a different line. Let me tell you how economists would typically bring that in, which is instead of just bringing in the income directly here, we would think of someone's utility function as a function of their consumption level. We talked about this before. And we would assume some sort of concavity in the utility function. In other words, the utility function looks like this. There's some curvature. Why will that help us here? It's going to turn out if you're poor, let's say this is I, the incentive I. Can anybody even see that down there? Is it being blocked by this monitor? Can you guys see that little I? Okay, raise it up. Okay. Let's say this is I. Okay, if I'm poor, I start from a very low consumption level. The change in my utility, so we're going to call that delta U, from having more income is pretty large. If I'm rich, I start with very high consumption. I have the same change I in my income. Because of the concavity, the change in my utility here is going to be small. Everybody got it? This is the way economists would model this. So most people would say, yes, the poor are going to respond more than the rich to a certain incentive of a certain amount. And the reason they're going to respond more is the marginal utility of consumption, the marginal utility is the delta U here, is much higher for the poor than for the rich. So they're going to respond a lot more. They're getting a lot more utility out of that money than someone who's rich. That first dollar, going from $15,000 to another 10K, $15,000 to $25,000 is a huge increase in income. And it gets back to this point that it's a very large proportional increase. That's why I didn't want to shoot you guys down. Your intuition is right, but we usually formulate it this way. If you're going from 100,000 to 110,000, it's a much smaller increase in income proportionally. But that sort of proportional increase gets captured in the utility function with concavity. So that's a great question. Yeah, Ashley. That's a really interesting point. So if to get the same bang for your buck in terms of utility, you need to pay rich people much more to incentivize them, but they're the at-risk population, it might make this kind of intervention less attractive. Now, the Duvall et al. Study takes place in a poor rural part of Tanzania, and they do find effects. So it could be the case that it does or doesn't work in rich areas, but they were focused on this one local effect. But your intuition following from this point is totally right. Yeah. The difference in what? Sorry? No, so S would be a separate thing here. So you could imagine, so let me the full kind of utility, if we were going to write this out, might be something like U sub I equals little u of my consumption, say in period 1, plus, say, this SI term, if I engage in unsafe sex. And then we would have the probability of survival, and this could either be P or PHIV, depending on your choice, times V. Okay, and again, in here, if you engaged, so this would be like if you engaged in unsafe sex, you'd get this. If you engaged in safe sex, you would get the incentive. Sorry, this would be PHIV. Something like that. So instead of just putting in your income as I linearly, oh, I'm sorry, I screwed this up. The I is going to be in here. Sorry, so that's the thing. So instead of just having I be put in linearly, your consumption, so I would come in here, would affect your utility. And to get at the heterogeneity we were talking about with income, we have to say something like your income, your consumption in period 1 equals some baseline level of income for this individual. Sorry, this would be C sub I, plus, say, I, if you got the incentive. And then all of this would feed back into the utility function. So very often when economists look at income or consumption, they take into account this concavity of consumption, the concave utility. And that delivers a bunch of different things. It gives us further sources of heterogeneity. It suggests poor and rich could respond differently. Okay? I know I went through that a little quickly, but hopefully the intuition is sort of clear. Let me pause for a second to make sure. Yeah. Yeah. So what's the comment?
Oh, I just said unsafe is going right. I think that's safe. Is the arrow right?
Yeah, S is the benefit to unsafe sex.
Okay.
So what ends up happening is with the old S star, these guys do unsafe and these guys do safe. With the higher incentive, when this moves to the right, now this becomes unsafe. Only the people with very high benefits, and this becomes safe over here. Does that make sense?
I thought you were saying with the arrow they got more people around unsafe.
Yeah, as the arrow goes this way, then the safe range increases. Yeah, sorry that wasn't clear. Let me pause again for questions. Part of the reason for doing this is just to show how a very simple model can be very easily extended in a lot of directions to shed light on a policy debate. So when you're thinking about a policy question, sometimes even a toy model, a very simple model like the one we did before, with a few tweaks, can give you insights about heterogeneity and other things. And there could be, of course, this is the kind of thing that could show up on a problem set or something like that, or an exam. I don't want to say that. I'm just saying it could. Any other questions? Okay, so that's Duvall et al. Again, not getting into the details. There's a lot of interesting details there. I'm going to ask about that on the problem set, actually, about the Duvall paper. But the punchline was this incentive actually did lead to a reduction in STIs in this population. So that's an interesting finding. And then the question is, might that hold in other populations like the issue that was raised, and how large does the incentive need to be effective? Okay, another policy. Do you have a question? Yeah. Yeah. Okay, I should label this better. So this is the utility from unsafe, the top one. Okay, and the bottom one is going to be the utility of safe sex. No, thanks for clarifying. So if you have unsafe, then you get the benefit of unsafe. If you have safe sex, you don't get that benefit, but you get the increase in I in your consumption. Does that make sense? Okay. So let's talk about another policy choice. We're just going to go through a few policy choices. This is the one we're going to go through in a little more detail because the Thornton paper revolves around this. And she was building on a claim that was being made when she started her study that information was going to be key to dealing with the epidemic. Now, we spoke quite a bit about this last time. We talked through the theoretical ambiguity of what would happen. If you give people information, will they tend to be safer or unsafe? I talked about some of the studies that found different things. But let's talk about the Thornton study. A, because it bears on this question, but B, it's also an interesting experiment, the design of the experiment, so it's also going to kind of expose you guys to a different type of research, related but different research design. Now, we spoke about last time had to do with what sorts of behavioral changes would you expect to see if everybody's tested and everybody finds out their status. Now, the model we had at the end of lecture last time, we had this R term, and R was my own perception of my risk, of my likelihood of being HIV positive. So now, once I'm tested, as long as that test is accurate, people are going to get pushed to either R of 0 or 1, like you're going to know you're infected or you're going to know you're not infected. And again, we talked through last time how it's ambiguous about how that would affect risky sexual choices, depending on how altruistic you are. If you find out you're infected and you're altruistic, you're going to have less unsafe sex. But if you're not that altruistic, maybe you'll just take more risks because you're not worried about your own infection anymore. So Thornton tests some of these ideas with data from Malawi. And beyond just understanding risky sexual behavior, one of the issues that comes into play when you think about these mass testing programs has to do with how the information doesn't only affect sexual behavior, but how it affects other economic choices. So if you test lots of people, if we're in a world where more people think that they are infected than are actually infected, which is actually seems to be often the case, then a lot of people are going to be finding out R0. They're going to be finding out their lifespan and life expectancy is actually longer than they thought it might be, and that can actually affect a range of other economic choices. If you have longer time horizons in almost any economic model, you're going to invest more. Invest more in human capital, invest more in physical capital, save more. So there could be a range of sort of investment benefits from letting people know they're uninfected, if that's what most people's misperception is. So what does Thornton do? It's another randomized evaluation. It's different than Duvall et al. It's not an experiment that is conditioned on sexual behavior. The randomized experiment revolved around giving people incentives just to get their test result. So it's providing incentives for people to get the information. And the reason why this is relevant is in a lot of the testing programs that are out there, and hers follow this model, is building on a real voluntary counseling and testing, or VCT approach. There's door-to-door surveying where people basically, there's a small blood draw that's later tested, but people have to go back and get the results of their test. Now that's starting to change because now there are finally these rapid HIV tests in the field that didn't exist even a year or two ago, but now exist. But until very recently, you have to get tested, you have to go to a lab, and then you have to go in and retrieve the results. And what people were finding in the early VCT programs in the real world is very small fractions of people who had been tested would actually go in to get their result, would walk to the local clinic to get their result. And that surprised some of us or some observers who were saying, wait a minute, understanding your HIV status is a matter of life or death. It's critically important. Why aren't more people going in to get their result? Can anybody think of good reasons why you might not want to get your result in this setting? Yeah. Yeah, so so to the extent that people know you're getting tested, they may deduce that you're infected, they may deduce that you think you might be infected, it may have implications for how they view your morality, as you were sort of alluding to, so that's one possibility. Yeah. So the question about religion came in, and it kind of ties into this moral question that maybe going in to get tested means you're admitting, or people think you're admitting you're having unsafe sex or sex outside of marriage or something else, so there could be reluctance to go get tested. Right, so even beyond the stigma of how others view yourself, if you think you're infected, do you really want to know? And in the era when Thornton is starting her study, which was before there were antiretrovirals, would you really want to know? So you're healthy now, and there's no treatment. Would you actually go and put yourself through the psychological trauma of actually finding out you're infected when there's nothing you can do about it? I think that's a very relevant question all of us would have to ask ourselves. Now, you might want to, because you might say, well, there's no treatment, there's other things I can do. I can start planning for my kids, planning for my family, doing all these other things. But we can all kind of understand the psychology of why you might not want to know. Now, of course, it's different when there's widely accessible, cheap, or free antiretroviral treatment. But before that period, maybe not. Yeah.